Okay, we are back for part 2 of this worksheet. And so now we're on to step 4 of this worksheet. And you will also find, I should remind you all, that every worksheet is going to be broken into steps 1 through 6 that we talked about in chapter 1 of the reading, because what we are trying to learn in this class is how to do the scientific process using statistics. And so we kind of set up the scientific method can be kind of broken down in different steps. And in this book, we're going to do it in 6 steps. And so here we are at draw inferences beyond the data. And so we have, this is where we had a sample, where there's, 10 observations and of one dog. And then you say, does this help us know something about the world in general? And it's really at this point where this class, statistics, is not really a math course. It's really a wisdom course that uses math, because math is something we're using all the time in stats, but it's not the main thing. The main thing is learning to be wise in regards to these sort of scientific investigations. And so wisdom would mean not jumping to a conclusion, but being careful in how we decide what's true. So we have 2 possible explanations here, that either our dog named Harley is either guessing randomly or understands something. Harley might not understand everything about the gestures, but either Harley's just guessing randomly or Harley has some understanding of what's going on. And so to be more precise about that, we want to talk about a parameter. So for a random process, a parameter is a long-run numerical property of the process. And so, for instance, we can talk about the parameter in this case might be the ratio of times Harley would get this experiment right. And so for question 9, what is the value of the parameter if Harley's picking a cup at random? So this should be a fraction or a ratio or a percentage is what this answer is looking for. If Harley's just guessing randomly, what's that ratio? What's that percentage? And then for number 10, what is the possible range of values greater than or less than some value for the parameter of Harley's not just? So for this question, I need 2 numbers, the less than and the greater than. And so you might remember from high school math, when you had numbers like so say you had numbers between 2 and 7, and then including 2, you could write that in different ways. You could use interval notation, which would be like 2 to 7, and then you would use like the hard bracket for including the 2 and the parenthesis for not including the 7. Or you could done like 2 less than equal to x less than 7. Or you could use words. You could also use words. So then for number 10, you should be giving me an interval of possible values. And remember that the parameter we should be thinking about is a ratio. So I used numbers 2 and 7. You should use different numbers. All right. Now, the chance model is really important for inferring what's really going on here. So in here, we're going to give you a partial definition. This definition we will fill out more later. Right now, we're trying to build on how statistics, because it's a wisdom course that uses math, wisdom should make sense with your common sense. And so we're just going to use kind of a common sense idea of statistical significance in this worksheet, but we're going to define it more rigorously later on in the course. I'll say, if we observe a result appears to be consistent with the chance model, we say that our chance model is plausible or believable. Okay, so it's statistically significant if it's unlikely to occur by chance, and otherwise it's plausible. Okay. So for number 11, explain how you could use a coin toss to represent Harley's chances if he's guessing between the two cups each time. How many times do you have to flip the cup to represent one set of Harley's attempts? What does heads represent? So make sure in this, your answer here, you answer all three of those questions. Okay. Now, and that you might be able to answer that question better if you also look at what happens next. So if Harley was guessing randomly each time on average, how many out of the 10 times would you expect him to choose the correct cup? Now, always be careful with words here. So how many is a key word there for, so this is not a question about a proportion or a percentage. This is a question of how many out of 10. Okay, so here is where our worksheet matches up with our activity we did. That was the first thing to do in our to-do list. So simulate one repetition of Harley's guessing randomly by flipping a coin 10 times. Why 10? And letting heads represent selecting the correct cup, as in success. And tails representing selecting the incorrect cup, failure. Count the number of heads in your 10 flips. Combine your results with the rest of the class to create a dot plot of distribution for the number of heads out of 10 flips of a coin. So then a dot plot is going to look like something like this. So again, you can create a dot plot using your, there's ways to do it with Excel. You can look up a video for how to do that. You can use, there's different web things to do it, or you can just draw a picture and post that picture, like put that picture into your answer, your document you're going to submit to me or to your instructor. So in that case, for a dot plot, you want to have numbers here. So you might have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so then we'll put dots above the numbers. So say for example, if you flipped the coin 10 times and you got 4 heads, you might put a dot right there. And then say you're looking at the class's discussion and seeing what other people got, and someone else got 7 out of 10, another person got 6 out of 10, and another person got 4 out of 10, so you put that dot above there. And let's say there's another 5, and another 5, and a 3, and maybe one more 5. And so that's an example of a dot plot, okay? So you can create it with software or draw it by hand and put it in your answer document. Either is fine. All right, so then the questions A and B then are, where does 9 fall in this distribution? So this will be different. That question 13A is different for every class that I teach this, because every class is going to have slightly different data. But then question B, based on your answer to part A, do you think it's plausible, believable that Harley was just guessing which cup to choose? This is a common sense question. So you should be able to understand, like, how often would you expect like a 9 to show up if we're just doing it randomly? So that helps us have a sense of how strange it was that Harley got 9 out of 10 correct. And so we're not just going by feel. We're not just kind of shooting from the hip here. We're being more precise and more careful, because we're learning wisdom in this course. And so we're learning how to be careful in how we determine what is true. And so instead of just saying like 9 out of 10, well, it must be this, we're actually looking at how often 9 out of 10 would appear if Harley didn't know. It was just guessing by chance. So now flipping a coin 10 times, a whole bunch of times, takes a lot of time. And so now we're going to use, our textbook comes with several applets that do this sort of thing. And so you can, there's a link if you click right there. Well, I'm in drawing mode right now, but on your mouse, you can click on the little number 2, and it'll take you to the applet, or you can always go to our Canvas page, student resources, applets, and then open that in a new window, and it's the one proportion applet. So you go there, and there you go. Now I already have it open, so I'm gonna just go back here. Okay, so now I'm going to pause this because I need to do a quick thing. So here we are at the app. And so we have probability of heads is going to be 0.5 because we have a fair coin. And then the number of tosses should be the number of the sample size. And we'll just do this once. So then the computer is flipping 10 coins for us, and it's counting the number of heads. There was 5 of them, so it dropped a little dot plot right there. So then let's say we do this 9 more times. Then let's not show the animation when we do that. Maybe even hide the coins. And if we do that, then having done it 9 more times, it's like I've had a class of 10 people all flip a coin 10 times and then count the number of heads they got. And so we have there. Now 10 is not a very big sample, so then the book, the worksheet asks us to do 990, which would bring us to 1,000. So then this is a dot plot, but all the dots are so close together, they're all just like stacking up. And so I guess it's not a dot plot, it's a bar plot, because we're looking at the different possibilities. So there could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. And then we want to know, back to our worksheet, look at the result of getting 9 heads and dot plot created in the applet. Would you consider this unlikely result? So if we look at there, look at the little, like, compare that area and area of, like, the area of 9 and maybe even area of 10. Compare that to the area here. And if this is really small, you'd say it's unlikely. So then, based on results of 1,000 simulated sets of 10 coin flips each, would you conclude that Harley would be very unlikely to have picked the correct cup 9 times in 10 attempts if he was randomly guessing? So remember that this app, we were assuming, we made the assumption right there that Harley was randomly guessing. And there was a 50-50 chance of getting it right. And so then we can see how strange getting 9 right would be if you were choosing randomly, right? Because even if it's a 50-50 shot, every once in a while you'll get 9 heads out of 10. That happens, but how often does it happen? Well, you can actually even count it. You can actually use this to count right there. And so 10 times out of 1,000 is the number of times that Harley would have, like, if Harley was just guessing, then 10 times out of 1,000 is roughly how often you'd expect to get 9 out of 10 correct. So that seems like 10 out of 1,000 times is not very good, not very likely. So then, this, again, we haven't taught you, we'll teach you some general, like, cutoff points. This is way past the cutoff point, so you should be able to use your common sense for this one. All right, so then for 17, do the results of this study suggest that Harley just guessing is a plausible explanation? So the key word then is plausible. Okay. So even if something can appear statistically significant, so the idea of the word plausible would mean it's not the same as asking possible, because it is possible to have gotten 9 out of 10, but plausible is talking about more of probability. And so it's not plausible if it's not likely. Okay, so then number 18, to make sure you understand the coin flipping chance model, what parts of the real study correspond to the physical coin flipping simulation? So to answer this question, make sure you say, what do the coin flips mean in regards to the experiment with Harley? And what does a flipping the coin head mean in response to and correspond to in regards to the experiment with Harley? And tails, what about the chance of head and then one repetition represents? So just like 1 to 1, you should say what the correspondence is between our chance model and the experiment. So our chance model is like the experiment, but assuming one of the two hypotheses, assuming that there is nothing going on, and we get to see how things might turn out if that were true. So the 3S strategies.
Sorry, could you say that again?
Oh dear. So the 3S strategy is talking about statistic, simulate, and strength of evidence. And so that's the key part here, is that for the statistic, remember that is our number that summarizes the sample. And then we simulate. So you assume, if you assume of the two hypotheses, you assume the by chance alone, and then you simulate that multiple times. And then you say, you compare then your statistic to your strength of to your simulation. So how strange is your statistic compared to the simulated stuff? And if it's very strange, then maybe something's going on. If it's not very strange, then you kind of say more research is needed. Okay, so remember, like that's we're going back to this now again. Like, what is the statistic? And then for 20 and 21, fill in the blanks there. And then we move to step 5 of this process. So step 5 is formulating conclusions based on what we figured out. So now here's the part where we say, based on this analysis, are you convinced that Harley can understand human cues? Why or why not? So remember to answer why or why not. Okay? Don't just give me a short little one-word thing, like explain. And then for 23, a single study will not provide all of the information needed to fully understand a broad, complex research question. Thinking back to the original research question, what additional studies would you suggest conducting next? So here's an example of where you should use complete sentences, and you should give me some details of how you would do another study based on this. And this is part of stats, is using your common sense. Like, this is a wisdom class, and so come up with something that makes sense that would be helpful. Okay, so then exploring further is generally step 6. And so then here we have one important step is to consider other models and what can be confirmed in other settings. So what if we do basically the same experiment, but instead of a person, we'll have a mechanical arm. Okay, so if we have a mechanical arm, and then say Harley does that one, and Harley gets it correct 6 out of 10 times with the mechanical arm. Okay, so then the simulated stuff we've already done, we can go back to that. So you still should have your simulated 1,000 simulations, flipping a coin 10 times, assuming Harley had no idea what any signal would mean. Then you can say, instead of 9, you can count 6. And my number will be slightly different from your numbers, most likely, but it should be fairly close. And so then, that's 373 out of 1,000. And so we're talking something that's more likely to happen. So that's going to change then. So you're going to go through all of this stuff again now, but with a different statistic, and you compare it. So then the rest of these kind of are similar to the ones above, but just a different situation now, with 6 out of 10 instead of 9 out of 10. And again, we're going to tell you a more specific thing for statistically significant, but this is, use your common sense here. You should be able to figure this out as far as like if this seems plausible. Okay? Now for part E, be careful with the word prove. Okay? Prove is a very strong word, so be careful with that one. And then compare the analysis between the two studies. How does the usualness of the observed statistic compare between the two studies? Does this make sense based on the value of the observed statistic in the two studies? Does this make sense based on how the two studies were designed? So explain. So there should be several sentences here. And then the hint, gives you plenty. So hopefully that helps you to complete this worksheet.